have it, because if not, we won't. If he does not use the card for a whole year, the balance on the card will be reduced by $5 each month that he continues to go unused. What will be the change in the value of the card if Arnott doesn't use it for 18 months? Okay, so what do we need to do? So he has a $50 gift card.
Multiply 5 by 18.
Okay. Why by 18?
Because 18 months and it reduces $5 every month.
Okay. But what does it say here?
Oh.
Right? So he kind of gets a 12-month free, right? So they're not going to charge him the fee for the first 12 months.
Why not? So we subtract 12 from 18 first?
Yes. And then
6, right? That's 6.
okay, and I heard a why not. So most companies, when you get a gift card, is not going to instantly subtract $5 from that card if you don't use it within the first month. I mean, think about it. Would you buy a gift card knowing that if your person you bought it for doesn't buy it in the first, doesn't use it in the first month, they're going to lose $5? Would you buy someone a gift card like that?
No.
No. So most cards give you a little bit of a leeway of to use it. And to be honest with you, most cards don't even take off money if you don't use it after a while. I mean, it wouldn't make sense to me. I would never buy a card like that. But anyway. Okay. So that is correct. So that means for 6 months, he's going to lose $5. So how am I going to figure that out? What is he losing?
So, I wanted to let you know that, I had to get back in the fact because I got kicked out several times.
Okay. I know some people are having internet issues. So, I mean, if that's what happens, just log back in. Okay? All right. So,
Where do you want us to do it?
Rebecca,
Yes?
your hand's up. You have a question?
Yes, what's your favorite candy?
Candy corn.
Okay.
During Halloween, it's candy corn. But regular time, it's like 100 gram or Baby Ruth, something like that.
Ew.
Okay, fine. All right, so,
Candies?
yes. All right, so what am I going to do? So for 6 months, I'm losing how much money?
$5.
Yes.
5, 6, or 6 times 7.
Which gives me what?
$30.
30.
Yep.
And then you subtract that by 50.
Yes. So what is left?
$20.
Yes.
After 18 months.
So $20 is what is left. Okay? Is there another way that I could have done this problem?
Yes.
How could I have done this?
You could have multiplied negative 5 by 6. Is that even possible? I think so.
Well, I could definitely subtract 5 each time, right?
Oh yeah, that'll take long.
Right. So it's not the most efficient method. 1, 2, 3, 4, 5, 6. So that's what the turn-in talk's kind of asking you. Did you use the same method? If not, explain your reasoning. So we could do repeated subtraction, but multiplication definitely is the most effective way. All right, so moving on to the building understanding. Jordan is scuba diving and stops each time she descends 15 feet to take a photo. Start at the surface. She does this 4 times until she reaches her final depth. What is her overall change in elevation? What number represents each change in elevation? So what does it say she does?
represents
Goes
negative
down
15.
15.
Right, so she descends 15. So what did you say, Xander, that represents?
Negative 15.
Yep, negative 15. Okay, so now we're going to use the number line to model Jordan's descent. So we start here, and then we go 1, 5, 10, 15. So my first descent is here. And then she does it again, right? So 5, 10, 15. 5, 10, 15. Somebody needs to mute their microphone.
It's Micah.
I can't unmute.
Apparently he can't mute himself.
I can't press.
I'll take care of it. Thank you. All right, so 5, 10, 15. So my last descent puts me where?
Negative 60.
Negative 60. All right, so the first thing we're going to do is write an addition expression to represent what we did. So negative 15 plus negative 15 plus negative 15 plus negative 15. Right? Because isn't that what I did? I went 15 plus another plus another plus another. So we talked about on the front that this is not the most effective way. So what could I have done?
Minus 15 times 4.
Yes, that would be the best way to do it. So that means the multiplication expression would be negative 15 times 4. Okay? So how should the value of the addition expression in part C compare to the multiplication expression? So how does this and this compare? Well, what do we call this? Repeated what? Yeah, repeated, R-E-P-E-A. So repeated addition is the same as multiplication.
What's funny is I said that before Xander said it, but my mic was muted.
Oh, sorry.
Actually, I said that too, but my mic was also muted.
What's about?
All right. So make a conjecture, so that means make a guess, about the result of multiplying a negative number times a positive number. So what do we notice happens when we multiply a negative number times a positive number?
It'll always be positive.
Did I get a positive? Did I get a positive number here?
Always get a negative.
Moving a positive number of any type would just.
A negative number times a positive number is always negative.
Yes. Always negative. So negative 15 times 4 gave me negative 60. Okay? Even if I flip it around, so even if I say positive 4 times negative 15, I'm still going to get negative 60.
Because you'll always go left or down on the number line.
It just, yeah, I mean, it's just the rule. It's just if you have negative. So here we went 15 4 times, and this means that we could do, and see, this one's will be weird because we're doing 4, but we're doing it negative 15. So it just sounds weird. So it always will still be this way. It always will be negative. Okay? All right. So that means we can finish our table. So a positive times a negative will always be
Negative.
Yep, and a negative times a positive will always be
Negative.
Yep. So, the product of two rational numbers with different signs is a
Negative.
negative number. So the overall change in elevation,
Negative 60.
right. So these are tricky because I think somebody asked me about this on the last test about overall change. And I want to say it was you, Xander, but I don't remember. So it's not asking for the distance, it's asking for the change. So since I went from 0 to negative 60, it's going to be negative. Just noticed I had a bruise on my, or black stuff on my arm, right? So that's why you have to look at what is the question asking you. So if it's asking for distance, yes, it's always positive. But if it's asking for the change, you have to tell me what was the change and what direction was I going. And since I was going negative, that's why it's negative 60. Okay? All right. So it says steps A through E support the first rule in the products of rational number table. Which mathematical properties support the second rule? So just like I said originally, this was the problem, right? That was the original problem. And I said that this is the same thing. What property did I use to reverse this?
Why is it 75?
So what property did I use?
Wait, it's not commutative. That's for
Why would it not be the commutative?
That's for adding.
Yep. No, there's a commutative property of multiplication. Yeah. So it is the commutative property of multiplication. So there is a commutative property of addition and commutative property of multiplication.
Question.
Yes.
Did we learn about the additive identity?
So the additive identity was A plus 0 equals A, and A times 1 equals A.
We see.
Additive inverse would be like A plus negative A. Gives me 0.
Okay.
That's what additive inverse is. All right. Moving on. So what do you think we're going to learn about now?
Division. I'm just kidding.
Well, we will learn about division, but if that was a negative positive, what's the other rule? Positive positive and a negative negative, right? So that's what we're fixing to learn about. All right. In orders of operation like multiplication, to work with negative numbers the same way they work with positive numbers, the operations have to satisfy the properties of operations. Use the rule you wrote in the first stack to complete the following. All right. So this one's a little tricky because they give us this statement here, right? And then that goes to this statement there. So hopefully,
1 next to 3, I think, is a 4.
huh? Oh, you talking about here? Yeah. Give me a second.
Yeah.
All right. So hopefully you can see that here they followed the orders of operations. So they did 6 minus 4, which is 2. So then 3 times 2 is 6. Okay? So this side, all of this side is called the order of operations. Okay? And then this side is using the
Distributive.
yeah,
I
PROP.
think I already know what it is.
Yes.
though.
So this side uses the distributive property. So as Fox just said, 3 times 6 is what we had here. And then he said 3 times negative 4. So that's what Fox said. So
Yeah.
that is correct.
And then the next box would be 12 since 3
Okay.
times
12.
4.
No, it's negative 12.
All right. So,
Negative 12, if you want to be correct.
well, it has to be negative 12. If I put 12 here, 18 plus 12, is that going to give me 6?
Mm-mm.
No. So Xander was right. It has to be negative 12. And we also just learned that anytime you have a negative times a positive, you get a negative. Okay? So 18 plus negative 12 is 6. So what they are trying to show you is that if you follow the orders of operations, or if you do distributive property, you're going to get the same answers. Okay? And that's what it's asking for here. What property is being applied to the first equation? Well, we already said distributive property, right? And does applying the rule for multiplying numbers with different signs give the correct result? Well, as we saw, yes, because 18 plus negative 12 gives me 6. Okay, so that's important. All right, let's move to C. Complete the following to make the statement true. Explain how you figured out the answer. So once again, this side is my orders of operations, right?
Yes, ma'am.
So 6 plus negative 4 is 2. And then negative 3 times negative 2 is negative 6. So now we distribute. Negative 3 times 6 is negative 18. So what does this number have to be here in order for me to get negative 6?
It would have to be 6.
It would have to be 12.
Yeah, it has to be positive 12, right? So,
Yeah, positive 12.
so what does that mean when I multiply a negative times a negative?
It would always be a positive.
Yeah. So that
And
means,
18 plus 12 would be 6.
Yep.
Negative 6.
so when you multiply a negative times a negative, it will always be positive. Always be positive. All right, so now we're going to look at that table. So we should always know that a positive times a positive is a positive. You learned that in elementary school. But the new one is a negative times a negative, which is a positive. Okay? So,
basically, if they're the same symbol, they'll always be positive.
if you're multiplying, yep. And if the symbols are different, they're going to be negative. All right, so the rule says the product of two rational numbers with the same sign is a positive number. Positive number. Okay, any questions on this page?
Just an example. How would you forget how would you solve negative 1 times negative 1, which would give positive 1?
That would be the answer.
What?
A negative, we just said, a negative times a negative is a positive.
That is confusing.
Why is that confusing?
I'm just saying, like, is there like a way to solve it? I know it's like simple, but it's like, is there a way to solve it, like going through a process or something, or is it just facts?
It's just facts. Multiply it and look at the signs. That's it. Multiply it, look at the signs. All right. So this one says, write another example like the example in step C to show why the product of negative 5 times negative 4 must equal 0. So this means that I have 5 negative 4s, right? Or I can have 4 negative 5s. But the tricky part is this negative right here. So this is really what I would have.
Very interesting.
And I'll show you why in a minute.
You say 0. I heard you say 0
I didn't say 0.
instead of 20.
No, okay. So, remember we know that a double negative gives me what? A positive, right? So negative times a negative is a positive. So negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative is a positive, and negative times a negative is a positive. So now I would have 20. So we know that this means we have 5 negative 4s, but because the 5 is negative, I have to put that on the outside of that parentheses. And that's why this gives me positive 4 plus positive 4 plus positive 4 plus positive 4 plus positive 4 equals 20. So that's another way to write it. All right. Now we're going to talk about division.
I think I got A down.
You think you got A down, okay? So you can use what you know about multiplying sign numbers to figure out the rules for dividing numbers. In multiplication, if one factor is 0, the product will be 0. In division, the divisor cannot be 0. Division by 0 is considered to be undefined. And if you put it in a calculator, it will give you an error message. It won't say undefined, but it will say error. All right, so we know that if we have a multiplication sentence and we want to check our answers, then we do the inverse, right? Just like addition and subtraction. If it's addition and we want to check our answers, then we subtract one from the other to see, do we get that original answer? So the same thing here. So 2 times 4 is 8. So 8 divided by what is 4?
2.
Yep. So therefore, 8 divided by 4
Is 2.
is 2. Really easy because all of my numbers are positive. So I'm going to end up with positive. So on this one, what, Xander?
I got a question.
Okay.
Is the calculator standard?
Nope. It is not a calculator standard.
Okay.
Savvy. All right. So on this one, negative 2 times 4 is negative 8. But if I want to check it, negative 8 divided by what gives me
Negative
4?
2.
Negative 2.
Yes. So that means if I divide a negative by a negative, I get a positive. Yep. And then negative 8 divided by negative 4 gives me
Is negative 2.
That's
Negative.
positive 4.
That's a positive.
That's a positive 4.
what did I say? Negative, my bad. Negative 8 divided by 4 is negative 2. Okay? All right, what about the next one?
Negative 8 divided by positive 2 would equal negative 4.
Yep.
And negative 8 divided by negative 4 is 2.
Yep. All right, and then the last one? 8 divided by...
Divided by negative 2 equals negative 4, and 8 divided by negative 4 equals negative 2.
Yep. All right. So my rules are for division. If the signs are different, then I end up with a
Negative.
negative. If my signs are the same, I end up with a positive. So the rules for multiplying and dividing are the same. Okay? So the quotient of two rational numbers with different signs are negative. And if they're the same, they are positive.
So kind of like the same rules for multiplication.
Yep. Yep. Multiplication and dividing are pretty easy because you follow the same rules versus addition and subtraction. Because remember, subtraction, you have to add the opposite, so it gets a little bit confusing.
Honestly, the rules haven't really changed much.
Nope. All right. Check understanding. I'm going to give you about 5 minutes. Shouldn't take you that long. Okay? And then if you want to start the on your own today, you are more than welcome to. But that is what we will do tomorrow, is the on your own. Okay? And you are doing all of the on your own. So 5 minutes. So I'm still missing Tyrone and still missing Aiden, right? Yep. All right, 25 seconds. Most of y'all are probably already done anyway.
Who's unmuted?
I can tell you.
I have no idea.
All right, 2 seconds, 1 second. Okay. All right, so what goes in the first box?
-2.
Yes, because we lost 2 yards. So then -2 plus -2 plus -2 should be what?
-6.
Yes. All right. So it says, how does this example show that the product of a positive number and a negative number is negative? So how did we show it? We added -2 3 times, and we know that we add a negative plus a negative plus a negative, we get a negative. Okay? All right, so how can I reverse it? So -6 divided by what?
3. Wait.
I could do 3. Yeah, that's one way. And what do I get?
-2.
Yep. And then could I do -3 divided by
-2.
Yep, and I get what?
3.
Yep.
3.
Yep. And then what do we know? Compare the rules for products and quotients. What did we say? They what? They follow the...
Wait, don't do it yet. Let me think. Inverse. Rules?
Yes. They follow the same rules. All right, so you guys have about 10 minutes. So once again, you can work on your own, or you can wait till tomorrow to work on your own. Whatever you want to do is fine with me. But you are doing all of them. Okay?
Well, I'm gonna head out, so have a good Monday.